Hello everybody. In this video, we are going to talk about error. And so before I talk about how we actually complete a full hypothesis test, the last thing I got to talk to you about is errors, right, that we can make, okay? So obviously, in anything that we do, right, and certainly in any hypothesis test that we run, no matter how careful we are with our results, there is still a possibility that we could be wrong, okay? So in statistics, there are two different types of errors that we could make, very aptly called type 1 error and type 2 error, okay? So type 1 error occurs when we reject the null when in reality the null is actually true. Okay, so a type 1 error occurs when we reject the null, we reject HO when null is actually true. Okay, errors occur when there is a difference between what we decide to do based on our test results and what we should do because of the reality. Okay, so that's a type 1 error. Okay, a type 2 error occurs when the exact opposite happens. So we fail to reject the null when in reality we should reject it, right? Because the null is actually false. Okay. The connection that this has to our significance levels and our hypothesis test is that the probability that we make a type 1 error is equal to your significance level. So whatever value you set for your alpha. Okay, so that is another part of our balancing act that we have to deal with as statisticians, right? Because we get to set our significance level, right? And typically when we raise the significance level, when we raise the probability of a type 1 error, typically that lowers the probability of a type 2 error, right? So we have to look at the situation, right, and the context of the problem and decide when we're setting our significance level which would be worse, right? Making a type 1 error versus making a type 2 error, okay? So honestly, one of the best examples that I have of this, right, is this idea of innocent until proven guilty, okay? So if we think about this as an idea, our null hypothesis in this statement is that a person is innocent. Okay, and then our alternative hypothesis, what we are trying to prove, is that the person is guilty. Okay, so a type 1 error would occur when we reject the null. Okay, so if we're going to reject the null and go with the alternative instead, the result of saying that a person is guilty is that they would be sent to jail, right? But the reality is that the person is innocent, right? So the error is occurring because the decision we make is not matching the reality of the situation. So in a type 1 error, an innocent person gets sent to jail. Okay, so the person being innocent, is our true null. And the person being sent to jail is the decision that we made to reject the null. Okay, then a type 2 error is the exact opposite, right? Where in a type 2 error, we're going to fail to reject the null. So we're going to stay with the null. We are going to operate and make our decisions under the assumption that the person is innocent. Okay, but in reality, that's not the case. In reality, it's the opposite, that the person is guilty. Okay, but we're going to base our decision thinking that the person is innocent. So we're going to let them go. Okay, so in a type 2 error, a guilty person is set free. Okay, so the guilty person is that actually our alternative hypothesis is true, right? Or you can think of it as the null is false, right? And the set free is us failing to reject the null. Okay, so as the statistician, you have to choose, okay, which of these is worse? Is it worse that we send an innocent person to jail, or is it worse that a guilty person is set free, right? So the best way to remember this, because this is the question I get the most often, is, okay, how do I remember which error is which? Okay, the best way that I have found to remember is that a type 2 error occurs when you fail to, right, reject the null. Okay, so a type 2 error occurs when you fail to reject the null. Okay, so remember that an error is determined by what you decide to do based on your test results rather than what the actual reality is. Okay, so we have this lovely little diagram here that kind of helps us summarize this idea. Okay, so on, oops, actually, I should go like this. So here, this, right, either the null being true or the null being false, that is the truth. Okay, or the reality. Okay, this here is what our test says to do. Okay, so i.e., it's the decision we make. Okay, so if the null is true, what we want is for the reality to match our decision, right? So if the null is true and we fail to reject it, that is the correct decision to make. Okay, but if the null is true and we reject it and go with something else, that is a type 1 error. Okay, if the null is false and we reject it, so if in reality the null is false, we want to reject it, right? So that would be a correct decision. But if the null is false and we keep it, right, we fail to reject it, that is a type 2 error. Okay. Another really common example that you'll see on the internet looks like this, with doctors telling men and women whether or not they're pregnant, right? So if a woman is actually pregnant, right, the reality, and the doctor says that she's pregnant, right, those two things match. Okay. If in reality you have a man who is not pregnant, right, and the doctor says that they're not pregnant, that is also a match, right? But if you have a man who very obviously is not pregnant, so the reality is that he's not pregnant, but the test and the doctor says that they're pregnant, right, that's a type 1 error. Okay. If you have a woman who very obviously is pregnant in reality, but the test, the doctor says you're not pregnant, right, and you make decisions based on what your test says, then you're going to end up with a type 2 error, right? So the result, right, the possible consequences here of perhaps this man right here believing that he is pregnant is that maybe he, like, you know, stops eating sushi and takes prenatal vitamins and does Kegel exercises, right? Not too bad, right? Like, that wouldn't be the worst thing in the world. Like, that wouldn't be the worst error to make. But in this case, with the type 2 error, if this woman who is very obviously pregnant goes with what the test says, which is that she's not pregnant, you could end up with some really terrible things, right? Like that woman may decide to like drink a lot of alcohol and like not take care of herself. And so the possible results of that are like fetal alcohol syndrome and like, maybe miscarriage or, some other thing, right? So in the context of this scenario, it would be much worse to make a type 2 error than it would be to make a type 1 error, right? Depending on the context of the problem, which error is worse will end up changing, right? So that's what we're going to look at in this example right here, okay? So here's what's going on in this scenario. So we have this potato chip producer, okay? Typically, when potato chips are made, right, they get potatoes from like some supplier, right, in a big shipment, right, and then they turn them into potato chips, okay? Rather than having to go through and check every single potato that is sent to them, right, by their supplier, typically what these companies will do is they'll take like one box or take a small sample, right, of the product that they get, and see if it meets their quality standards, right? So if the company in this case, whoops, one moment. Sorry, y'all. I'm getting a bunch of messages. So in this scenario, if the producer finds from the sample that more than 8% of the potatoes have blemishes, right, then they'll assume that most of the rest of the batch is bad or bad enough to be sent back, right, to get another load, right? Otherwise, the entire truckload will get used to make potato chips, okay? So they're going to run a hypothesis test here where we're going to assume that the true value or the true percentage of potatoes that have blemishes is 8%, right? And we're trying to decide if we want to keep them or send them back, right? And we're going to send them back if the proportion is actually greater than 8%, right? So that's our alternative hypothesis, right? So we want to describe a type 1 and a type 2 error in this context, okay? So the decision that you make for a type 1 error is that you are going to reject the null. Okay, that's the decision that you make, okay? So in context, this means that the producer finds significant evidence that the proportion of damaged potatoes is more than 8%. Right, so we're rejecting the null, which means we're going with the alternative hypothesis instead. So that means in this truck, if we're going with the alternative hypothesis, the decision we would make is that we would send the shipment back, right? Okay, that does not match the reality. The reality is that the null is true, right? The reality is that the shipment is fine. Okay, so then a type 2 error is the exact opposite. So the decision that you make as the potato chip producer, if you're making a type 2 error, is that you fail to reject the null. Okay, so we're going to fail to reject the null. So we don't have enough evidence that this shipment of potatoes has like a bunch of blemishes, right? So there's not enough evidence that if I could spell, that would be awesome. So there's not enough evidence that the proportion of blemishes is greater than 8%. So the decision that you make based on that is, okay, if it's not greater than 8%, we're going to keep those potatoes. So they keep the shipment, okay, but it doesn't match the reality. The reality is that the null is false, right? And the shipment has potatoes with a high percentage of blemishes. Okay, so then the question then becomes, okay, so which is worse? Is it worse in this scenario to make a type 1 error, or is it worse to make a type 2 error? Okay, and I'm going to argue that it depends on which of these you think is worse. As a company, which of these do you think is worse, right? Okay, because you have one of two consequences here. Either, right, you have a loss of time and money due to sending a good shipment back. Okay, so that would be a type 1, that would be the consequences of a type 1 error. Or a possible loss of revenue due to damaged potato chips, right? Damaged chips made with blemished potatoes. Okay, so that would be a type 2 error, right? Often on the AP test, you can write something very similar to what I've written here, right? That you could make an argument for either a type 1 error being worse or a type 2 error being worse, right? You just have to be able to, whichever one you choose, make sure you can justify it, right? Okay, so there's one other problem very similar to this one that's talking about customer service in a at a fast food restaurant. So I would love for you to pause the video, give this one a try, and then check back with me to see how you did. Alrighty, folks, so go ahead and check your answers against mine. So in this scenario, we have a manager of a fast food restaurant, and they want to reduce the proportion of customers who have to wait longer than 3 minutes, right, when receiving their food. Okay, so the true proportion of customers who had to wait longer than 2 minutes, those should both say 2 minutes. Sorry, typo there. Okay, so so that actual proportion is 0.63. So the manager's goal is to reduce this, right? So to reduce this proportion, the manager assigns an additional employee to assist with drive-through, right? Meaning taking them off of somewhere else, right? Then they gather data, right, and test the following hypotheses, right? The null here is that after adding the additional employee, nothing has changed, and the proportion still is 0.63, right? And then our alternative hypothesis that we're trying to prove is that actually adding the employee, that extra employee, did reduce that proportion, okay? So a type 1 error in this case would occur when you or the manager rejects the null and goes with the alternative hypothesis instead. So the manager finds evidence here that the proportion is less than 0.63 after adding that additional employee, when in reality, the null is true and the probability, or the proportion rather, has not changed, right? So the manager thinks that they've made a good decision and lowered the proportion, but it hasn't actually done anything, right? So my possible result, right, or consequence of this is that the manager might be overconfident, but the customers are upset because the wait time has not changed, okay? And then a type 2 error is the exact opposite. So for a type 2 error, you fail to reject the null. That's the choice that you've made, okay? So we're gonna stay with that after adding the additional employee, that the null is still true. So that proportion of customers that have to wait longer than 2 minutes is still 0.63. So the manager has not found sufficient evidence that the proportion has lowered after adding the additional employee, but in reality, the alternative hypothesis is true, and P has actually decreased, right? So the possible consequence of this is that the manager doubles down and adds even more employees, and then ends up having to pay them overtime, right? Or have to hire more people in order to decrease the wait time. That's a possible consequence. You could go the other way and say another consequence is, well, they've realized that this extra employee added to the drive-through doesn't actually do anything, so they're going to reassign that employee, and then maybe the proportion of people that have to wait longer than 2 minutes in the drive-through line goes back up to 0.63. So you could have upset customers in that instance too, right? So then the question, which one of these has a more negative consequence? I personally think that a type 1 error is going to be worse in this case because you end up with upset customers, right? And a misunderstanding that could make the manager like not listen to customers when they say that they've actually had to wait like a longer time in the drive-through, right? But I did say that you could make a financial argument for type 2 being worse, right? If you're going to have to add and pay more employees, right? You could make a financial argument, like a bottom line type argument for a type 2 error being worse, right? On the AP test, if you're asked questions like this, especially on a free response question, as long as you can justify the choice that you made, right, saying which is worse, the type 1 or the type 2 error, then you will get the points for this. Often in a lot of these scenarios, you can justify either one of those errors being the worst of the two to make, right? Okay, so that is it for error. That's it for this video. In the next one, and the next couple, I'm going to actually walk you through the full procedure for running a hypothesis test. So I will see you in the next video. Bye, everybody.